best friend to 23. She left her body and hovered above me. My best friend to 23. I heard the heavens crying above me. They gained an angel, I lost a friend. I felt like dying again and again. I went through hell, stared at death, but I keep fighting with each living breath. I saw no way out from where I stood. Felt like the fire had burned me through. Now you're gone, I'm alone. I guess it's time to get better. Through the pain, I will go alone. If I fall, break my bones, I will scream even louder. 'Cause I'm not dying alone. I lost my best friend.
सर मुकेश का पेमेंट ब्लॉक हो गया।
आपके पेपर चेक करने पड़ेंगे।
Look straight at the sun. My mind's going in circles. I'm trying to fight. Getting these voices inside to stay quiet. Go to the place where all this began. To start again. Oh, you won't see the light until the dawn breaks. No, till it's all said and done, you won't know what it takes. Gotta make a wrong turn and turn around. Gotta fall fast to pick yourself up off the ground. Until you get lost, you'll never be found. And you can't start again until you break down.
Good afternoon, everyone. Welcome all to the 5-day national webinar organized by the Department of Mathematics, Yokshetra Institute of Management Studies. I'm Shilpa, Assistant Professor, Department of Mathematics. Our college, with a motto, Inform and Form to Transform, is a premier professional training institute, an arts and science college affiliated to the University of Calicut, Kerala. We strive to cultivate a sense of social and civic responsibility in our students, thus empowering to serve the humanity and the country. The Department of Mathematics, offering BSc degree program, aims at providing the students with ample opportunities to improve their organizational skills and group dynamics. Apart from the academic performance, the department encourages their participation in curricular and co-curricular activities to bring out their best. Mathematics is the most beautiful and most powerful creation of the human spirit. It is not about numbers, equations, computations, or algorithms. It is about understanding. It is a broad discipline with an application-oriented potential to address several problems in engineering, sciences, and business through mathematical, computational, and statistical tools and techniques. It involves building a mathematical model of the application using mathematical theory and interpretation, this behavior in the context of original application. Through this webinar, we are discussing how the world consists of situations, events, and phenomena that can be sorted out using the right mathematical tools, and to use data to draw sensible conclusions and use mathematical knowledge and skills to make life more comfort. Moving on to the program, it's my great pleasure to welcome our today's resource person, Dr. Neelam Yadav, Assistant Professor of Mathematics, Statistics and Computers, LS Raheja College of Arts and Commerce, Mumbai, Maharashtra, to this webinar. Heartily welcome you, ma'am. And then I will the organizing committee, Reverend Dr. Matthew George Warrail, Director, YIMS, Principal Dr. Tommy Anthony, Vice Principal Reverend Dr. Lalu Olikil, and Professor Rajan TK, Head Department of Mathematics, to this online platform. It's my great pleasure to welcome our advisor, Dr. K. Veerakumar, NGM College, Pollachi, and our zonal committee members, Ms. Beena, Dr. K. Venkadeshan, and Dr. A. Dinesh Kumar, and our webinar coordinator, Radhika V.S. Now I cordially welcome all the faculties, research scholars, and students to this 5-day national webinar. Last but not the least, all the technical committee members and our well-wishers. Once again, on behalf of Department of Mathematics and Yogshetra Institute, I warmly welcome you all to this webinar and wish that these sessions will be really informative and helps to understand more on the applications of mathematical and statistical tools. Next, I invite Reverend Dr. Matthew George Warriel, Director, YIMS, to deliver his message.
Good morning, my dear teachers and my dear students. First of all, let me congratulate the Department of Mathematics for taking initiative for organizing a webinar on mathematical and statistical tools in the applied level. You have organized eminent personalities as resource persons. In mathematics, precision and accuracy is very important. Students many a time make errors and mistakes, and there are some biases in their minds. But maths always need accuracy, precision. So I hope and expect this webinar will highlight on how students can make more accurate in their answers and more precision in the methods. Wish you all the best for the organizers and the resource persons and all the participants. Wish you all the best. Thank you.
Thank you, Father. Let me introduce our eminent resource person, Dr. Neelam Yadav. Working as Assistant Professor, LS Raheja College of Arts and Commerce, Mumbai since 2013. She has qualified BSc, B.Ed, MSc Mathematics, MA Education and got certificates in Data Science, R Basics and Business Analytics. Obtained PhD in Mathematics in Uncertainty Analysis of some Markovian process. She has proved her academic excellency by receiving gold medal in MSc Mathematics, Best Student Award for BSc B.Ed. She has extended her expert service as paper setting in University of Mumbai and editorial board member of various national and international journals. She has published a total of 29 research papers in international journals approved by UGC. She is also a guide for PhD in mathematics. Moving on to the session, kindly hand over to ma'am.
Thank you, ma'am. Thank you, ma'am,
You can
for such
continue.
a nice introduction.
Thank you.
I would like to thank YMS College for providing me the opportunity to express my views on a topic which is very much in demand in market nowadays. And the topic is data analytics with Python. Let me share my screen. Is my screen visible?
Yes, ma'am.
Okay. So the topic is data analytics with Python. First, we will understand what is data, then what is analytics, and then why we are using Python. Then we will go for one practical example. Now, many of us must have Instagram, Facebook, Twitter, or WhatsApp account. Have you ever thought what exactly you are doing when you send a smiley, or when you upload your picture, or when you write a post? Actually, you all are generating data. Here, data can be in the form of a smiley or pictures, or your review about a restaurant or a movie. So basically, data is any information in raw or unorganized form that is referred to or represent any conditions, ideas, or object. Nowadays, availability of data is not a problem, as huge amount of data can be generated through human machine or human machine interaction. For example, if you are sending smiley, you are generating data. If you are uploading picture, you are generating data. If you are writing a review of a restaurant or a movie, you are generating data. So availability of data is not a problem at all. Now the next question is, why we are interested in collecting data and how this will add value to the business. Until your data add value to the business, it is of no use. So after collecting data, it can be used for getting more insight. And data helps in the development of a data product. Now, what is this data product? You might have seen when you bought something from the Amazon. For example, if you bought a dress. So you might have seen Amazon give you certain recommendation that the person who bought this item has also purchased this or something similar kind of recommendation. So what is this? This is nothing but your data product. Likewise, whenever you open your Facebook account, you might have seen the recommendation like list of people you may know. Or whenever you watch a movie on the Netflix, it might show you other movies you may enjoy. So what are these? These are nothing but your data product. So with your data, you get data insights, and from this insight, you develop a product which is known as data product, and this data product will add value to your business. Now, another example of your data product are your driverless car or Google car. So the whole concept of Google car is, with the help of data, it is detecting all other requirements for driving the car. For example, it is collecting data how far the next car is from you. Where are the traffic signals? So it is collecting all the data so that it can drive itself. Another example is recommendation engines. As I told you, whenever you buy a certain product, it suggests you that along with this product, you can buy this one also. So this is your data product. Another very common example is your Google Map. So the Google mapping is helping you to find out what is the right route, or which road there is a traffic, or which road there is a toll booth. So data is important because it helps us in making better decisions. It helps us in solving the problem by finding the reason for underperformance. Now, what underperformance? Suppose some company is not performing well. By collecting the data, we can identify what was the reason for this underperformance. So data helps you to evaluate your performance. Now, this is all about data. Now, what is analytics? So analytics is defined as the scientific process of transforming your data into insights for making better decisions. Even without the data also, even without doing analytics also, you can make the decision, but you cannot make the better decision without analytics. Now, by the virtue of your experience or intuitions, you can take the decision that also sometimes may be correct. But with the help of the data, if you are making decisions, then that will enable you to make better decision. Now, based on the phases of workflow and the kind of analysis required, there are four major types of data analytics. Now, the first one you see is descriptive analytics. What is descriptive analytics? It tells you what happened. For example, a company may give you a data and tell us, now analyze this data. So with the help of descriptive analytics, you can tell what happened. It seeks to provide summary of facts and figures in an understandable format. They can describe in detail about an event that has occurred in the past. Now let's consider an example. For example, Airtel Guide give me a data and tell me now study this data. So on the basis of the analytics, let us say I came to a conclusion that last year the number of users were 20,000 and in 2010 the number of users were, let us say, 50,000. So there is a decrease in number of users. So I can tell the guy that, okay, this is your data, and according to this data, I came to the conclusion that your sales is decreasing, your consumers are decreasing. So basically, descriptive analytics tells you what has happened. Now come to diagnostic analytics. Diagnostic analytics is a form of advanced analytics which examines data or content to answer the question, why did it happen? For example, if your users are decreasing, then why did the number of users are decreasing? So it will tell you why did it happen. So, suppose we are meeting a doctor for consulting and he will try to understand why this has happened. So that kind of analytics is your diagnostic analytics. So diagnostic analytical tools aids an analyst to dig deeper into an issue so that they can arrive at the source of the problem. Like the doctor will identify if someone has got some disease, then what was the source of the problem. Now the next one is predictive analytics. Predictive analytics will tell you what will happen. So it will help to forecast trends based on the current events. When you say predicting, obviously it says that it is discussing about something that will happen in future. So predicting the probability of an event happening in future or estimating the accurate time it will happen will all can be determined with the help of predictive analytical models. So in predictive analytics, one of the tools is like your regression analysis. There you consider that there are several independent variables, several dependent variables, and how they are interrelated. So that kind of study is nothing but your predictive analytics. Now the last one is prescriptive analytics. In prescriptive analytics, basically one deals with the idea what you can do to make things happen. So such type of question. So it is a set of techniques to indicate the best course of action. It tells us what decision to make to optimize the outcome. And the goal of predictive analytics is to enable quality improvement, service enhancement, cost reduction, etc. Now in this picture, what you can see ladders are there, but the person is not making proper use of them. So the danger in using quantitative method does not generally lie in the inability to perform the calculation. But the real threat is lack of fundamental understanding of why to use a particular technique or procedure, how to use it correctly, and how to correctly interpret the results. Now come to Python. Why Python? Why we are using Python? Because it is very simple and easy to learn. It is an open source software. It is an interpreter based, dynamically typed. When I say dynamically typed, in the sense that in some programming language, you have to declare variables in the program. But here you need not to declare. You just assign the value and it understands the type of the variable. It is extensible. Extensible in the sense that when you are coding in some other language, it can be extended with Python. It can be embedded in the sense that if you have made your program in Python, it can be used in other platform also. And it has a huge or extensive library. Now, where you can use this Python? for making any desktop and web application, for database application, networking application, data analysis, machine learning, IoT, that is Internet of Things, and AI applications and game. Now, another reason for using Python is most of the companies use Python. For example, your Google, Facebook, NASA, Yahoo, eBay, these all companies are using Python. Now, we will understand this with the help of the data. So, we will understand how we are using one of these techniques to understand the data and to draw the result. So, I am using Python as my programming language. And I have considered I am doing regression analysis on the data. Let me share my screen. So let us consider this a very simple example. Now, if you check in the first cell, so in the first cell, I have imported certain libraries. So these are inbuilt libraries which I will be using. For example, since I want to do numerical computation in my data, I am importing the library NumPy. So my first sentence is import NumPy as NP. So wherever I will using the library for numerical computation, that is NumPy, I will represent this library with the symbol NP. If I am using the library for data frame, so I am using pandas and I am importing it as PD. So I have imported these libraries and this will I am using in my data set. So we will discuss about these library little later. Let us consider the data set first. So I have imported my data set. Now, if you check here in the data set name is faithful.csv. So faithful is the name of the file. .csv, it is the extension. CSV stands for comma separated value. It means your values are separated by commas. Now, this is the location of my file. So first I have imported my file. So how you are importing? Since your file is in CSV format, I want to convert this file in data frame format. So I am importing this file with the command pd.read_csv. So this is the command which we use to import any comma separated file. And I am storing all these values in my variable new. So now after importing the file, I want to check how my values look like or how the data looks like. So in order to understand how the data looks like, I don't want to see the whole file. I am interested in seeing only the first 5 rows of my data set. So now what is the command for this? Head. So head command is basically used to see the few rows of the data set. Now new is my file name. New dot head means whatever is the file you have already converted it into data frame and you have stored in the value new, and from that file I am interested only in the first 5 rows. So how you will get the first 5 rows? By the command dot head. So new dot head. If I keep this bracket open, it will give me the top 5 rows. Now if you check here what Python is doing, Python starts its indexing from 0. So whatever is my first row, Python gave it as index 0. Whatever is my second row, Python gave it as index 1. Whatever is my third row, Python gave it at index 2. And fourth row as an index 3 and so on. So the indexing in Python language starts from 0. So 0, 1, 2, 3, 4. These are my top 5 rows or initial 5 rows in my data set. But if you check the column here, the first column is unnamed 0, 1, 2, 3, 4, 5. So it is quite possible that in my data file, there may be some serial number. So the heading was not given, only 1, 2, 3, 4, 5 numbers are given. Then the next column is of eruptions and the next column is of waiting. Waiting is basically your waiting time between two eruptions. So if I look at my data, so actually I don't need the indexing here. So I have two things. Either I delete my first column, or because my first column is of no use, or I don't want to use the indexing given by Python. What indexing Python is giving? 0, 1, 2, 3, 4. I don't want to use these. I can simply use 1, 2, 3, 4, 5. Or what I can do? I can delete my first column because this is not giving me any information. This is just the serial numbers. Okay, so what I am going to do, let us say I don't want to use the indexing given by Python. Okay, I only want to use the indexing which are given in the first column. So instead of importing like how I imported earlier, I have introduced one more thing. What is that? Index underscore call equal to 0. What this command will do, whenever you import the data file, it will make sure that whatever are the first column, whatever is the first column, it will consider that first column is your index column. So now, earlier your first column was this unnamed 0, that is 1, 2, 3, 4, 5. Now this time I want Python to consider these as my index numbers. So 1, 2, 3, 4, 5 like this. So I have to give one extra command which is index underscore call equal to 0. Again, I want to check whether my import is done in the proper way or not. So again, I'm checking the first 5 rows. So your location dot head, and whenever you give head with the empty parenthesis, it will give you the first 5 rows. So now if you check here how these first 5 rows are imported, the indexing will now start from 1, 2, 3, 4, 5. As I told you, by default, Python will give indexing from 0, 1, 2, 3, 4, 5. But what we have done, we want the indexing to be used whatever is in our first column. So in the first column, the indexing was from 1. So I am using the same indexing. Now let us say instead of these 5 rows, I want to check the 10 rows. So what you have to do, in this empty parenthesis, just mention how many rows you want to check. Let us say I want to check only 3 rows. So I will give the number 3, then control enter. So if you do like this, Python will give you the top 3 rows. If you want to check, then let us say 10, starting 10 rows. So in place where in the parentheses, in the brackets, just write the number 10, press control and enter, and it will give you the 10 rows. So it is giving me the 10 rows. So if you are not giving any values in the parentheses and pressing control and enter, it will just display the first 5 rows. Now I want to check the last 5 rows in my data set. So what I have to do, instead of head, you have to give a command that is tail. So now the command is new dot tail. Again, if the brackets are empty, it will give you the last 5 rows of your data set. So these are my last 5 rows. If I want to consider last 4 row, just give the number 4 in the bracket, press control enter, and it will give you the last 4 rows. If you want the last 10 rows, just write number 10, press control enter, it will give you the last 10 rows of the data. Now understanding of data is important. So most 80% of your time, whenever you are doing any data analytics, 80% of your time goes in understanding and cleaning of the data. Now I want to check what type of variables are there in that data. That is my data type. So what is the command for this? .info. So new .info with empty parenthesis. So when you press Control Enter, you will get something like this. Now what you are getting from this information, that your file name is new now. It is a data frame. Now how many rows are there? How many columns are there? Every information you can get from this. Now if you check these values 0 and 1, as I told you, the indexing in Python will start from 0. So 0, column, eruptions and waiting. It means in my file, there are 2 columns. One column is eruption and one column is your waiting. The column eruption is at index 0. It means first column, whatever in my file, whatever first column is there, that is eruption. Waiting, the index number is 1. So whatever waiting is there, that is my second column, the indexing is 1. Now 272 non-null. What it means? It first look here, index here 272 entries are there. So in my data set, there are total 272 rows. So it will give you the number of rows. So from where it is starting? From 1 to 272. Now come here, eruption. In eruption, how many non-null entries are there? Non-null means blank cell. So nothing you have written in those cells. So total rows are also 272. And in this case also 272 values are there, which is non-null. Sometimes it may happen that your cells are blank in a particular column. Let us say in eruption column, few cells are blank. Let us say 10 cells are blank. Then what you will see here? 262 non-null. So it basically tells you whether you have some empty cells or not. Now the data type, what is your data type? That is float. Float means the values are in decimals. So first column is eruption. 272 values are there and these values are not null. These are non-empty columns. And the data type is float, means these values are in decimal. Now next here, the second column is your waiting. In waiting again, there are 272 entries and the data type is int. Int means integer. So in this data set, I came to know that there are 2 columns. One is eruption, second one is waiting. In a total number of rows in my data sets are 272. In eruption column, all the 272 values are non-null, not empty. In waiting column also, there are 272 values which are non-empty and the values are integer type. While in eruption column, the values are in float or in decimal. So although from here also we came to know that there is no empty rows in the data set. But still we can check with the help of another command. And the command is null dot sum. So here new dot is null. So basically what it is checking, are there any empty cells in my columns? So my first column is eruption. Is there any empty cell in columns? If yes, then add all those numbers. For example, let us say in eruption column, at 5 places, the values are not there. It means 5 cells are empty. So 5 cells are empty, then in place of 0, what would be the value? 5. So, but in this case, in eruptions, you can see 0. So what it means? It means that in eruption column, there is no column, there is no cell where you don't have any entry. All the cells are occupied and they are having some float number. Now come to second column. Second column is waiting. Again, the value written in front of second column is 0. It means in waiting column also, all the cells are occupied with integers. So there is nothing, or there is neither a single cell which is empty. Now, as I told you, understanding and analysis of data is must. So 80% of your time goes in this only, that how you are analyzing data, how you are cleaning the data or pre-processing the data. So now comes to univariate analysis. In univariate analysis, what we are going to do, univariate means here we will understand the properties of the variables one by one. Now, if you look here, in this case, there are two variables, eruptions and weighting. Eruption, the values are your float. Weighting also, values are float. So basically, in both the column, the values are numerical values. Whenever you have numerical values, you can count the total values. You can find their mean. You can find their standard deviation. You can find the minimum value. And then quartiles, all the three quartiles, Q1, Q2, Q3, the maximum value, all this you can do. Okay, so here since both the columns are having numerical value, we are interested in finding some basic information. And how we are finding? With the help of the command describe. So this I am using whenever my data is numerical. So both the values are numerical, eruption and weighting, and I have used a describe. So it tells me the first value is count. Count implies 272.00 something. So it means there are 272 entries in eruption column, 272 entries in weighting column. Now come to mean. The mean value of eruption column is 3.487783, while the mean for weighting column is 70.89 this. Now come to standard deviation. The standard deviation for both the columns are given, the minimum value, and all this data is given. So with the help of describe command, you can describe this. Here both the columns are numerical. Now let us consider a case. For example, your one column is there which is categorical. Let us say the first column is gender and there are two values, male and female. So if two values are there in the first column, gender, male and female, so you cannot find the mean. At that time, what we will be interested in? Finding the frequency. So that's why I told you understanding of data is must. Depending on the variable type, we will perform our analysis. So if I have, let us say the first column is gender, so instead of performing or instead of finding these mean, standard deviation and other things, I will be more interested in finding the frequencies. Like how many males are there, how many females are there. So you depend on the data, you have to decide your analysis type. Now consider the next one. Identify and treatment to outliers. Now what are outliers? Let us consider in your data set, you have values 1, 2, 3, 4 and 5. And the next value is 1000. So if you compare this 1000 value, this is far away from rest other value. So if you are having very positive or a high negative value in your data set, so it will lie far away. We call such value as an outliers. And why the identification and treatment of outliers is must? Because if you don't treat the outliers, it will affect all your result. For example, let us say you have in data 1, 2 and 3. So, and you are calculating the mean, and the mean value is, mean is sum of observation divided by number of observations. So you calculated the mean. Now let us say I introduced a fourth value which is 10,000. So now your values are 1, 2, 3 and 10,000. So if you calculate the mean now, so the mean value would be very high. So basically, if you add any outliers, so it will affect your mean. So that's why we have to first identify the outlier, else they will change our results drastically. So how we are going to identify the outlier? With the help of the box plot. So we have plotted one box. Now if you see here, so the below line is your minimum value, the above line is your maximum value. So we cannot see any data point which is below this minimum value line, okay, or which is above the line, which is above this line. So it means there are no outliers in the data set. So if there are no outliers, then it is perfect. But if outliers are there in our data set, then first we have to remove these outliers. And there are various kinds of methods which are available, such as vinsorizing technique or capping and flooring. So there are 5 to 6 different kinds of methods which are available to treat the outlier. But in this particular case, there are no outliers, so we can go ahead. Okay, one more thing which I guess I forgot is, here if you look here there are non-null values. All the values are non-empty. But if there are certain, if in some columns the values are empty, then what you have to do? So whenever the values in a particular column is empty, first we have to fill those cells so that we can perform the analysis. Now how you will fill it? If let us say your first column is categorical, for example gender, male, female, it is written and few cells are empty, then how you are going to fill those empty cells? Now there are several methods. One of the method is you check the frequency of the column. Let us say the total number of males are 50 and let us say the total number of females are 80. So we will fill that particular cell of the value which is highest. So the highest frequency is for female. So we will fill that column, we will fill that cell with the female. So like this, there are several methods. If your column is, let us say, numerical one, so and the particular cell is empty, then how you will fill those values? You can fill it with mean, you can fill it with median. If it is categorical, you can fill it with mode. So other than this also, there are certain methods which are available to fill the empty cells. In this particular case, we don't have any empty cells, so we are not going to perform anything. But if there are empty cells, then first you have to fill the empty cells. Now proceed further. Now we are interested in finding the correlation. So we have plotted the values of x and the values of y. On x-axis, we have plotted the waiting time. On y-axis, we have plotted the eruption. So now if you consider, if you look here in this graph, the graph is somewhat increasing type of graph. Okay, and this is linear graph. So you have from this also, from the graph also, scatter plot also, although you can see that the graph is almost like linear, but still in numbers, and both of them are correlated. But if you want to find the correlation with in numerical form, what you can do? You can use the heat map. Now in this particular command, SNS is basically my Seaborn library. Why I am using this library? This library I am using to plot my graphs. So heat map is one of the function, and this function, can you see this graph which is there? A0 equal to true. If A0 equal to false, you won't get the coloring over here. Since A0 equal to true, so that's why you are getting coloring and numbers. Now if you check here, eruption versus eruption, that is 1, means self correlation is always 1. But if you check here on the cell which is colored in black color, so one side it is waiting, next side it is eruptions. It means the correlation between waiting and eruption is 0.9. So it means these are correlated. Now we are going to do, we are using here some machine learning techniques. What is this? Whatever is my data set, let us say in my data set there are 100 rows. So on my 100 rows, I am not going to make my model. Because if I make model by considering all the data, how I can test my model, whether it is performing good or bad. So what I will do, let us say if I have 0 to 100 rows, if I have, let us say 1 to 100, these are my rows, then I will partition this data. I will divide this data into two parts. One I will use for training, and the one bunch I will use for testing. Now here, if you check the starting code, what it is, you have two columns. One is weighting, one is eruption. First thing is you have to decide which column is your y variable and which is x variable. And before that also you have to decide what analysis you can perform on such kind of data. Now, if you look at the variable, eruption is your floating number, weighting is your integer number. So both are basically numerical columns. Now, by our intuition, we can say that the eruption depends on waiting time. So eruption is your dependent variable. On what it is depending? Weighting. So weighting is your dependent variable. Since eruption is in numerical form, so you can do your regression analysis, and if let us say eruption is categorical, then you can do classification analysis also. So in this particular case, we are doing regression analysis. And our y variable, which is eruption, is dependent on our weighting, which is our x variable. So you might have studied the equation y equal to mx plus c. So y is your dependent variable and x is your dependent variable and c was your intercept. Okay, m is your slope. So in the same way, eruptions are my dependent variable and weighting is my independent variable. So whatever is my dependent variable, I am storing the value in the variable x. Whatever is my dependent variable, I am storing the value in the y. So in the x, I am storing all the values of weighting, which is my independent variable. In the y, I am storing all the values which are in my dependent variable, and the values are of eruption. Now, as I told you, I am dividing my data into two parts. And how I am dividing? 70% of the data, I will use that data for training my model. And remaining 30% of the data, I will use it for testing the model. So in order to import this split from sklearn library, I am importing train test split. What this train test split will do? It will split my whole data set into two parts. One is train, one we call as test. So let us say my 70%, and as I told you, what is my training size? Training size is 70%. So that's why I have written here 0.7. So I have divided my data set into two parts. One is training, one is testing. In training parts, I have 70% of my data. And in that 70%, whatever is my whatever is my weighting, I am representing that with this variable x underscore train. Then whatever is in my testing and the weighting column, I am representing it by x underscore test. In my eruption column, I am representing it by y underscore train, and the data which goes for my testing purpose, I will represent it by y underscore test. This is my function train test split. How it is, what it is splitting? It is splitting x and y. And what is my x? Weighting. What is my y? Eruptions. What would be my training size? 0.7. 0.7 means 70% of the data I am using for training. It means remaining 30% I am using for testing. random underscore state equal to 100. What it means? You can fix this value to any number. Random underscore state, you can fix it 5, 7, 10, 11, 20. It is up to your choice. But what it is doing, it is shuffling the data, and every time it makes sure that in the training, same number of rows will come. For example, if let us say I have my data and the data is like this: 1, 2, 3, 4, 5, 6, 7, 8. Let us say these are my data. So in the first time, whenever it is dividing it into test and train, let us say first row is coming, fourth row is coming, fifth row, sixth row, and eighth row is coming. Okay. So next time when you rerun the model and you have fixed the random state, same rows will be picked up. And what will happen if you don't fix this random state? That it is quite possible that first time 1 is coming, next time 3 will come, next time 7 will come, 8 will come, and so on. So it will keep on changing if you don't fix this random state. But if you fix the random state, every time it makes sure that it will pick the same number of rows for your analysis. So if it pick the same number of your rows, so your data accuracy will not change. Now come to model building. So we have divided our data into test and train. Then we have xtrain and xtest. We have ytrain and ytest. Now we have to build the model. So in the model, what I will do? I will build my model only on the training part. So in training part, I have xtrain and ytrain. Xtrain represent weighting, ytrain represent eruptions. Now I am combining both these values. I am combining xtrain and I have correspondingly ytrain. So concat command is used to join both of them. So I am using concat command to join weighting and eruptions. X is equal to 1, it means you are joining them column wise. Again, I am checking after joining this, I have one data frame. I am checking the top 5 rows of my data frame. So when you check the top 5 rows, what rows you get? 66, 99, 105, 49, 160. So these are the rows which are automatically picked up when you perform test train split. And since you fix the random state also, so every time these rows will only get picked up while you will build your model. Now I want to make a linear model with the help of ordinary least square method. So what I have done, I am using OLS. OLS means ordinary least square. Here, check this way of writing. This is eruptions weighting. So eruption is your dependent variable, weighting is your independent variable. Let us say I have several variables which are my independent variable. For example, y equal to mx1 plus m2x2 plus m3x3 and so on. So in place of writing all these numbers, what you can do after this tilde sign, you can just put a dot. So eruptions, this tilde sign, and put a dot. So it will take all others variable as your independent variable. So when you perform the regression analysis, you get a table like this. Now what thing you can see from this table? Your dependent variable is eruption. Your model is OLS, ordinary least square method you are using. I have run this particular file on 21 July. By what time I run this file? This is the time. Now here, what is the important thing which you have to check? Come here it is intercept and weighting. If you look here, the value of coefficient minus 1.9745 and the weighting coefficient is 0.0772. Now, how you will write your model when you will get the coefficient like this? So if you remember, the general form is y equal to mx plus c. So let us say, let me open a new one. So your general form is y equal to mx plus c. Here instead of y, what you have? you have eruptions. So your eruptions equal to M. Your N is the coefficient. If we check our model here, what is the coefficient value? Check here, the coefficient is 0.0772. This one. This is your weighting coefficient. So I can write it like this, 0.0072 x. X is your independent variable. Our independent variable is weighting. So it is weighting plus C. C is your intercept. Now if you check the intercept, the intercept was, check this value, minus 1.9745. So minus 1.9745. So this is my intercept. So I can rewrite this as, I am writing this constant part first, minus 1.9745 plus 0.0072 multiplied by weighting. So this is my model. So eruptions equal to minus 1.9745 plus 0.0072 multiplied by weighting. So this is how I will get my model. So now what other things we have to check in this model? Our R square value. That is coefficient of determination. Now if you check here, the R square value is 0.801. It means 80.1%. And your adjusted R square is 80%. So we have two things, R square and adjusted R square. So generally these tell us how our model is performing. So in both the cases, on and roughly we can say that 80% of the time our model is performing good. So R square value should be high as possible. Now instead of checking R square, basically we take adjusted R square. What is the reason? Here you have only one dependent variable, which is weighting. But let us say you have many dependent variables. At that time, what you will do? You will not check R square, because sometimes if you keep on adding variables in your model, your R square will increase. But it is not necessary that adjusted R square will increase. So adjusted R square is not increasing. It means adding that particular variable in your model is making no difference. So while R square will always increase if you keep on adding more variable in the data. So that's why we check adjusted R square value. So in this particular case, adjusted R square is 80%. So our model is the good one. Now this is how we apply our model. But this model is based on certain assumptions. If the model does not follow those assumptions, you cannot apply this model. So you have made the model, that's correct. But the important thing is you have to check the assumptions on which this model is built. So what are the assumptions? If you remember, the general linear equation is mx plus c. But in data analytics, we generally denote it by symbol y equal to b naught plus b1x plus epsilon. Now, what is this epsilon? It represents your error term. So basically, it is your error term. So however good we make a model, but still we assume that there are some errors. And this model is based on certain assumptions, especially about the errors. Now, what are those assumptions? Your model should be linear, it should follow normality, homoscedasticity, then independently, identically distributed. But what it basically means? The error should be a random variable with mean of 0. The variance of error is same for all values of independent variable. The values of error are independent. And the error is a normally distributed random variable. Now, how we will do this? We have to check all of these assumptions one by one. If these assumptions are not met, You cannot make such model. Whatever linear model you have made, that's not a correct one. Or you can do certain calculations and you can improve your model. So let's come to linearity. In linearity, I am plotting a graph between eruptions and waiting. Now, if you see the graph, it looks almost linear. That okay, whenever waiting time is increasing, eruption is also increasing. Okay, so this is a linear type of model. But what else you have to check? That E is a random variable, error is a random variable with mean of 0. Now, what I have done in the line 19th and 20th in this piece of code, df is my data frame. In that data frame, I am adding a column with the name fitted underscore value. What is this fitted underscore value and what is this residual? Let us again understand this. Let me open the Paint new file. Now let us say you have the values x and you have the values y. You made a model according to the equation which we have generated. Let us say the values are 1, 2, 3, 4, 5. And let us say these values are 3, 6, 8, 10, 12. Let us see. Now, I have calculated the model and my model was eruptions equal to minus 1.975 plus 0.0072 into waiting. Now, in that particular example, this was my model. Plus 0.0072 into waiting. Now in this model, what is my waiting? Waiting is nothing but an x variable. So let us say I am putting the value of x, means waiting. So when you put waiting equal to 1, that is x equal to 1, you will get the certain value of y. And that value of y we denote by the symbol y hat. That is our predicted value or fitted value. So what is your fitted value? Whenever you put the values of x or your waiting time in your linear model, the values of y you obtained is your fitted value. Let us say the value of y I obtained is 2.5 and let us say this is 5.5. This is, let us say, 8.5. This is 10.5 and let us say this is 0. So what is my column y cap? This is my fitted value. Now what are residuals? Residual is the difference between your fitted and your actual y value. That is your y hat minus y. So whatever is the difference between my fitted and my actual, that is my residual. For example, 2.5 minus 3. So it is minus 0.5. 5.5 minus 6. So it is again minus 0.5. 8.5 minus 8. So it is plus 0.5. 10.5 minus 10. It is plus 0.5. And this is your minus 12 like this. So these are all nothing but your residuals. So I have made two columns. One is fitted and one is residuals. Now, in the next line, what I am doing? I am calculating the mean of residuals. And your residual is nothing but your error. So residuals is your error. So now I am calculating the mean of my error. And the mean is this value into e raised to power minus 16, 10 raised to power minus 60, which is approximately equal to 0. So my first assumption is true that the error is a random variable with a mean of 0. Now let's come to homoscedasticity. What is homoscedasticity? That is your constant variance. So how you will check this? We will plot a graph between fitted values and residuals. Now again, come here. Cancel this one. Now my fitted values was y hat. My residuals was y hat minus y. So basically I am plotting a graph between my fitted value and my residuals. So this should have constant variance. It means if you plot all these points, so these points should be randomly distributed. if the points are not randomly distributed, or you can say if you are getting some specific patterns. For example, if you are getting a pattern like this. So what it means? It means as the value of y hat increasing, the errors are also increasing. So it is not a constant variance. So if the constant variance is not there, it means assumption is violated. It means you cannot perform linear model. Or if you are getting something like this, let us say you are plotting the point and you are getting something like this. It means the model is not linear, so better you go ahead for non-linear conditions. So we have to plot the graph between fitted value as well as the error, and when we plot, the error should have constant variance. That is, it should lie between, should be randomly distributed and it should be like this, lie on a horizontal band. Now the next is normality. So normality we check by two plots, PP plot or QQ plot. Either way you can check the normality. So your all the data points should be around this red line, which is at 45 degrees Celsius. So this is the line of 45 degree. So and blue is your data point. So the data point should be around this line only. It means normality is also satisfied. So we can check it by PP plot, we can check it by QQ plot. Now here the next is your error should be identically distributed. Now if you check this plot, it looks like a bell-shaped curve. You check here, it is almost like a bell-shaped curve. So all our assumptions are satisfied. If all our assumptions are satisfied, it means the data is performing well. All the assumptions are satisfied. We have made our model. So this model is based only on the 70% of our data set. But we want to check whether this model performed good on the data, unseen data, or on our test data. So now we will use this model for our test data and check how well it performed. So again, what I have done, I have taken the X test, Y test, combined them column wise with the help of concat command. Then I have created one new column, predicted. So earlier I have two columns, weighting and adaptation. Now I have made another column which is predicted. And what is this predicted? On the basis of my weighting value, I substitute this weighting value in my model. Whatever is my y hat value, that is my predicted values of y. So actual values of y are 4.317, but the predicted value is 4.274906. Actual value is 3.733, but the predicted value is 4.12. So this way I will get the predicted value. Now I am interested in, so this is approximately close value, so my model performed well. But I want to check the error. What is my error? How much error is there in my test data? How much error is there in my training data? So there are two ways in which you can check. One is mean absolute error, one is mean squared error, one is root mean squared error. So you can use any one of them. Now I performed this error on both the training data as well as testing. Now if you check here on training data, my error was 0.252. But if I consider my testing data is 0.23, so both are approximately same. Likewise, my mean absolute error and root mean square error is almost approximately same. It means whatever my model is performing on training data, likewise it is performing approximately similar on my testing data. So this is the way how you will perform data analysis on your data. Now this is the very simple case because my data is already cleaned enough. But in general practice, whenever you take data from any website like Kaggle or like UCIS repository, the data might not be that clean. So the 80% of your time will go in the data cleaning. Once you clean your data, once you pre-process your data, then it is very easy to perform any model. Thanks. That's all from my side. And if you have any question, you can ask. Any questions?
Participants, you can clear your doubts if any. You can on your mic and ask.
Any queries, please?
Looks like no queries there.
Okay, everyone, participants is clear about the topic Python.
Hello, ma'am. Good afternoon.
Good afternoon.
Ma'am, Python is a programming language like other languages like that, ma'am.
Yeah, it is very easy to use. Look, I am from mathematics and I learned this at this stage, just few months back,
Yes,
like
ma'am.
8 to 9 months back only. It is
Okay,
so easy and you can use even R for data analysis also. Both are good, but in generally in companies, they use Python.
Yes, ma'am. Okay, ma'am. If you share some of the library functions now, it will be useful for us, ma'am, to work out.
Libraries are basically actually depend on data type, what data type you are using. But the main libraries which we include is like pandas, like NumPy, like Matplotlib, like Seaborn. These are some basic libraries.
Yes,
Rest,
ma'am.
it depends on your use case. If you are using decision tree, separate libraries. If you are using classification algorithms, separate libraries. So it will come by practice. You will came to know that. And the basic one is sklearn, scikit-learn we call it as. And that is basically for the splitting of data. Like we have split the data into testing part and training part. So that we use scikit-learn.
Yes, ma'am. Thank you, ma'am. And session was very good, ma'am. We are very thankful to you, grateful to you.
Thank you so much. Actually, in such a small session, it is very difficult to tell each and everything. So,
Yes,
although linear regression itself will take 4 hours or 5 hours, so
yes,
many
ma'am.
concepts are there which I'm not able to explain in such a short time.
Oh, thank
But
you, ma'am.
thanks.
But what you explained was very useful, ma'am, and clear also. Thank you, ma'am.
Thank you so much.
Thank you, Nirmala, ma'am. And thank you, ma'am. And there is a query,
Yeah.
ma'am.
Yeah.
What is the difference between R and Python? The question from Muthukumar M. What's the difference between R and Python?
Both are programming language. Look, syntax of both are different. If you see the syntax in Python, I have used dot symbol if I want to fetch certain things from a column. While in R, we use dollar symbol. If you will consider a particular column, you will use dollar symbol. So basically, both are used, both are good, both are useful for your statistical analysis. So if you want to just focus on statistical analysis, R will be good. R is also easy to understand. R is also an open source. But if you are aiming towards your job in your industry or something like this, then Python is also good.
Okay, thank you,
Anyone
ma'am.
you can use. Yeah, thanks.
Okay, one more question from Ramya Swami. Which one
Yeah.
is better, Python or R software?
According to me, both are better, but I am using Python, so I prefer Python.
Okay, thank you, ma'am. Anybody, any more queries? Any more queries?
Hi, ma'am. This is Kushwan. Python and R is a case-sensitive languages, but
Yeah.
generally R is used in sort of Unix Unix operating systems, and Python is mainly used in Windows operating system. Can you please suggest me which one will be the good one, like when we use in Unix or the Windows operating system?
Look, you can use both. As I told you, actually it depends on for what purpose you are using. If you are using especially for statistical purpose and for research purpose, go ahead with R. But if you are aiming towards for dealing company data, or if you want to go and do job in company, then prefer Python. Although both are good for statistical analysis, but R is mostly preferred by researchers.
Thank you, ma'am. Thank you so much.
Thank you, ma'am. Any more doubts?
Hello.
Yes.
Ma'am, can you tell me, can we do the MATLAB function in Python also?
Right now, I have not yet done because MATLAB is different environment, but I guess it can be embedded. If you have written any Python program, that can be embedded in MATLAB.
Okay, ma'am. Thank you.
Hello.
Yeah.
Hello. Am I audible?
Yeah, you are audible.
Okay, this is Sagar from Mumbai. I wanted to ask that what all mathematical concepts can be practiced by using Python?
You cannot say that mathematical concept can be used, but you can say mathematical concepts are required if you are performing analysis via Python or via R. So you need mathematical concept and statistical concepts also. For example, let us say your data is categorical, okay, and you are performing mean. So is there any use to perform the mean? For example, in categorical data, you have gender, male, female, and your output is you perform the mean, and your output is, let us say, 1.7. So does that 1.7 make sense? No. So
No.
you should have the understanding in which scenario we have to perform what.
Okay.
Okay, so in that case, mode would be best. That you have taken, okay, the frequency of this one is higher, this one is lower. So you are using all these concepts, mathematical and statistical concepts, to gain the better understanding of the data. And these are using, and Python is just to implement the results.
Okay. Thank you, ma'am.
Welcome. Any other questions?
Ma'am, one more question. Hello, ma'am. So audible?
Yeah.
What's the difference between Python and MATLAB?
Both are different programming language. Again, MATLAB, people are using mainly for researchers are using this, and Python is used everywhere in the industry, although both are programming language.
Okay, thank you, ma'am. Any more questions, participants?
Now I invite Ms. Srija for offering vote of thanks.
Thank you, Shilpa, ma'am. Good evening, all. Myself, Ms. Srija T.S., Assistant Professor, Department of Mathematics, Yogyakarta Institute of Management Studies. I deem it as a great honor to thank all on behalf of the Department of Mathematics. First of all, I extend my gratitude to our guest speaker, Dr. Neelam Yadav, who delivered a wonderful session on the topic Data Analytics with Python. It was really an informative session and extremely helpful for all participants. Thank you, madam.
Thank you, madam.
Next, I mention my deep sense of gratitude to the Yogyakarta College Management, especially our director, Reverend Dr. Matthew George Varil, for granting us the permission and the required facilities. I extend my gratitude to Dr. K. Veerakumar, advisor of the webinar, and the zonal committee members, Ms. Meera P., Dr. K. Venkatesan, and Dr. A. Dinesh Kumar. Right. Next, I am grateful to the Assistant Director, Reverend Father Shaiju Pariyat, and the Bursar of the college, Reverend Father Shaju Angevitil, for the encouragement provided. My profound gratitude to our Assistant Director and our Principal, Dr. Tommy Anthony, and Vice Principal, Reverend Dr. Lalu Ulikel, for constantly motivating us. I would like to thank HOD Mathematics, Professor T.K. Rajan, for the moral support and guidance provided to conduct the national webinar. I extend my sincere thanks to the webinar coordinator, Ms. Radhika V.S., Assistant Professor, Department of Mathematics, for organizing such a wonderful section. I am also thankful to Mr. P.V. Sujit and Mr. Girish for their technical support, and the technical coordinators, Ms. Shilpa and Ms. Tija, for the constant efforts rendered for the webinar. I am thankful to all my colleagues for their wholehearted support and guidance. Also, I mention my deep sense of gratitude to all the participants for their cooperation and support. Once again, thank you all.
The feedback link for today's session is shared in chat in both Meet and YouTube live chat. The link will be open for 30 minutes. The certificates will be provided for only those who give feedback. Tomorrow, we have a session on analysis of algebra by Dr. K.P. Uma. At the same time, thank you all for your cooperation and hope to see you tomorrow. Thank you all. Thank you.
Thank you, ma'am. Thank you, ma'am.
Thank you, ma'am. Thank you. Thank you.
you.